Well, good. I see people are getting on the board and some people have finished the level 1. So let me talk about level 2. You found a server hosting the defacement file when you found the traffic that went backwards, and you can now go outside Splunk into threat intelligence. If you Google an IP address, you will see various results. And here, let me find that IP address, which I should have here. There, all right. So I found an IP address. And so if you Google an IP address, simplest thing to do, people will just record what they've been finding. Same thing works with phone numbers. If you Google an IP address, it'll tell you there's different groups, Threat Miner, Alien Vault, Threat Crowd, and so on, that just gather open source intelligence. So Alien Vault, for example, will show you the history of this IP address. And this is how they caught the Iranian attack a week or two ago. Somebody sent emails pretending to be from the Proud Boys, telling Democrats they had to vote for Trump. And just a day or two later, the FBI and other people were out there announcing they were sure it was Iran. And I was very surprised by that. But what they said was they found an IP address in a video, and that IP address went to an IP address that had been used in previous attacks. And you see here, here's the various host names of this. And some of them are clearly tied to this challenge, like Wayne Corp Inc. and such. And there's a flag where you have to pick off one of these names. So this is very commonly done. People reuse compromised servers for a campaign of different attacks, and you can identify the people attacking you that way. That's threat attribution. So the other thing I wanted to demonstrate a bit of is this brute force attack. So somebody is performing a brute force login attack against I'm Really Not Batman. And I have some hints here of how to do it. So I'm going to move this to my other window so I can keep it visible and do some of it here. So if I go back to the search, and I want to find HTTP events that use the post method. So I'm going to just search for HTTP, and to make it faster, I'm going to do some sampling, like 1 in 100. That'll make it much faster. And now I see some events, and I can find the HTTP method, which is here. And as usual, they're mostly get or post, and some are head. And if I'm looking for a login, brute force attack is where they try logging in with a bunch of different passwords. So that's usually a post. So I can use, now I'm looking at the posts. And so I found 150, but that's at 1% sampling. If I turn off the sampling, I should find 15,570 events. And let's see, there we are. Okay, so these are all the post events in this database. Now, I would like to exclude the events from the vulnerability scanner. And you know the name of the vulnerability scanner. You can, now the most efficient way to use Splunk is what's going on here where you have name equals value. Then it looks right in one name field and it finds that value. But you can also use Splunk just the way you use Google. I can just put a word here, and then it will just look for that word anywhere in the event. And so I can also exclude a word that way. So I'm going to exclude the name of the vulnerability scanner, which is Acunetics, and it's going to look for events that meet this criteria, that source type, and that HTTP method. And if it has the word Acunetics anywhere, it's going to exclude that event. This Splunk people don't like it when you do this because it wastes more processor time on the server, but it works, and that's all I care about. So you can do it that way. And now I'm down to a smaller number of events, 441. So to understand these events, I see the HTTP requests and such, but let's take a look at the HTTP form data, which, maybe it's just form data. There it is, it's up here. Okay, the form data gives you a summary of what it does. So these events go to Explorer. This event looks sort of awful. Installing some kind of PHP package, that might be a malicious activity, but it's not a brute force attack. And here's more stuff that isn't very clear what it means. So those top 10 values didn't have what I want. So another good thing to know is how to see all the values. To see all the values, For some reason, they don't let you see more than the top 10 or the bottom 10 in this screen. But if you go to rare values, it will perform the query up here. And if you take the Splunk online course, you get the Splunk certificate, they teach you this language, which is not very much more than just Google Advanced Search, but you pipe to rare, limit equals 20, form data. By default, it shows you a graph, which is kind of silly, but the statistics is what matters. This shows you the least common 20 values. And you could see them all by just changing that number. This is an easy way to get a list of all the values. And the first few are different things, but if you scroll down here, now you can see this is a brute force attack. Username equals admin, username equals admin, and over here, password is Arthur, password is Big Daddy, password is Blazer. This is an attack where it's just trying a list of words to try to log in. So I want to find just the events that are participating in this attack and get rid of everything else. So I could use username or admin or password as further filters. I think I'll just use admin and passwd and add those words to my query. So I get rid of this summary stuff, and it's admin and password. And that might limit me to just the brute force attack and nothing else, because that's what's of interest to me now. Now, if I look at the form data, these look pretty good. Username is admin, Big Daddy, Blazer, Fire, and so on. I appear to have pretty well limited it down to just the brute force attack. Now, when Splunk shows you events, it shows them to you at the most recent event first and then backwards in time. So you can notice something about the time here. The first event is at 2:48. The next event is at 2:46, a minute or two earlier. This one's at 2:46 and 51.3 seconds. And the next one is at 2:46, 51.1 seconds, only a fraction of a second earlier. And if I go to the last event, this was 2:46:51. If I go to the last event on the last page, 2:46:51 is where it started, and 2:45:21 is where it is now. So in a minute and a half or so, it tried 400 or more passwords at the rate of several per second, and then there was a 2-minute gap, and it came back again. So what's going on here, this is the normal pattern of a brute force attack. And you can see it if you look at the HTTP, there we are, HTTP user agent. Notice how there's 2 user agents, and there are 412 events with a user agent of Python and 1 event with an actual Mozilla user agent that you'd really see if you're using Firefox or something. So this is what happened. They ran a Python script that made a bunch of requests with a user agent of Python from this URL library, which is one of the common libraries used to make HTTP requests. That was 412 guesses. One of them succeeded, so some message popped up on the screen of the attacker saying, I found the right password, here it is. And a minute and a half later, they logged in from a browser. So that gives you the structure of this brute force attack. And there's a series of flags where you have to find the first password used, the correct password, the time between the time when the scanner found the password and when the attacker logged in, and so on. But those are a few techniques that will get you in the right ballpark for them.